Alright, our last lesson we simplified rational equations, and now we are going to solve rational equations. We still have to deal with the issue of denominator. However, you can, because of the equal sign, just multiply through by the common denominator. So what we essentially are looking at here is a common denominator of x minus 2 times 2x minus 10. Because of the equal sign, we can do this nice little trick. And what you should notice is that this x minus 2 will cancel with this x minus 2, and all you're left with is 7 times 2x minus 10. And then on the right side, the 2x minus 10 will cancel, and all you're left with is x minus 2 when you consider distributing the LCD on both sides of this equation. Since you simply have two fractions, essentially what you have done is cross multiply. It's the same effect. Now, one thing that you do have to check for, and I'm going to point this out before we go through, is the extraneous solution. What would make your problem undefined? And since we have a fraction, much like when we were graphing rational equations, we have to take into consideration what's going to make your denominator 0. So sometimes it helps to start out with what can x not be, what is not in the domain. And what is not in the domain is 2 and also 5. Both of those numbers would make your denominator equal to 0. So x minus 2, equals 0. X equals 2, and then you have 2x minus 10 equals 0, and that solves to a 5. So x can't be either 2 or 5, so you need to go ahead. And if you go ahead and plug those in and see what is eliminated from your domain, then you don't necessarily have to go back and check when you go back to write your solution. So let's keep on going with the problem. So you're going to have 14x minus 70 equals 11x minus 22. And we want to take our x's together, our numbers together, which gives you 3x equals to 48, and x goes evenly into 48 16 times. Now, 16 is not either 2 or 5. It would be a very good idea for you to plug in 16 and make sure that this really is a solution, and that also checks to make sure that you have done the problem right. Second, alright, so this time I don't just have two fractions, but I do have two denominators, actually three denominators, because underneath that 5, what do you have? You've got a 1. So let's look at the one that's factorable. I've got x minus 1, x plus 1. So your LCD is going to be x minus 1, x plus 1. Now you're going to multiply that LCD by all three parts. Don't forget this part. So x minus 1, x plus 1 times this first fraction causes the x minus 1 to cancel, and you're going to have 7 times what's left. So plus 1. And then the 5 in the middle, there is nothing to cancel with that 1. So you're going to multiply everything by the 5. And if at this point you recognize that is x squared minus 1, just go ahead and write the x squared minus 1. And then the same thing. This last one, this x squared minus 1, will cancel with the x minus 1, x plus 1. And you're just left with a 6. So we're going to distribute everything. Took a little shortcut right here. You don't have to take the little shortcut, but I took the little shortcut. And what I see is I have a square. I don't really like a negative and a square combined, so I'm going to take everything over to the other side. And I'm going to make this 5x squared minus 7x. And when I add the 7 and the 5, I get a 12, and I'm going to subtract that over, and I get a negative 6. Now this is a quadratic that is certainly factorable. And I have 5x plus 3 times x minus 2, which when I check my foiling, that's negative 10 plus 3, which gives me a negative 7, so we're good there. Now one thing before I keep going, one thing I did not do is I didn't check my domain. What values would make my denominator 0? X cannot be plus or minus 1. So that's always a good idea to do from the start. And I'm going to set each one of these factors equal to 0. I get x equals negative 3/5, and I get x equals 2. And both of these certainly do work. You just need to plug them back in and check on that. Okay, so let's start with this one by factoring that long trinomial over here, x minus 5 minus 3. Okay, so looking at that, I can easily see that the things that would make my denominator 0, which would undefine my expression, would be x can't be three or 5. Okay, so what we're going to do now is we're going to multiply through by this common denominator of x minus 5, x minus 3. So essentially what you're doing is each fraction you're going to multiply by what is not in the denominator. So I have 3 over x minus 3. So I'm going to take my 3 and I'm going to multiply by what it doesn't have. And what it does not have is x minus 5. The middle one, I'm going to have my 2. I'm going to multiply that by x minus 3. And then the 4 has everything, so I'm not going to multiply anything by it. So then I'm going to distribute. I have 3x minus 15 plus 2x minus 6 equals 4. Combine like terms. 5x minus 21 equals 4. And then 5x equals 25. I'm going to add the 21 over, and x equals 5. Now I'm checking up here, and what I have is that x can't be 5. And I have x equals 5. So what we have here is a situation of no solution. Alright, lastly, we have two fractions. Everything has variables, which means you can count on foiling, simplifying, and factoring again, probably. But I do want to start with what would make my problems as they are undefined. Now what I want you to look at is the denominator right here. The numerator, as far as what makes something 0, doesn't matter. We're looking at the denominator only. So for this left side, what would make this denominator equal to 0 is negative 1. And how did I find that? I set 2x plus 2 equals 0, and I solve for x. And you're going to do the same thing here with 3/5 plus x plus 5, and the thing that would make this denominator 0 would be a negative 5/3. So just like on the last slide, if you get either one of those, it's going to be no solution, or a reduced solution. So I'm going to multiply by what the other one doesn't have, and this one needs a 3x plus 5. So I'm going to take 4x minus 3. I'm going to multiply it by 3x plus 5, which, yes, is cross-multiplying. And then I'm going to multiply 6x minus 3 by 2x plus 2. And we're going to FOIL both sides here. So I've got a 20 minus 9 is plus 11, and then minus 15. That's on one side. And then on the other side, I have 12x squared, and then I have a 12 minus 6, so that is a plus 6, and then minus 6. Alright, so what I see already is that I have matching x squared terms, so I'm going to go ahead and just cross those out. There's no need to combine those, because they're going to subtract out anyway. And then I'm going to start combining, so I'm going to bring over the 6x, make this a 5x. And then I'm going to take over the negative 15, and I'm going to add 15 to 6, which gives me a 9. And I get x equals 9/5. And that solution should work, and I encourage you to check on that.